Hello everyone, welcome to the channel of Algocamp. So now on this particular channel, we are actually releasing a series on data structures and algorithms where we are going to talk about some of the most important data structures and algorithmic topics which are extremely important for your upcoming software engineering interviews. Apart from that, these are some of the I would say topics that are very helpful in your day-to-day engineering job as well. We have already released a couple of series around searching, right? And we got a really good response on that. And from here, we are going to put really some awesome content around DSA. In most of these lectures, we will try to ensure that we focus on the intuition building aspect of the things, that how you are able to think about something, what are some of the things that people actually neglect but are going to clear some of the really important fundamentals. We are going to see coding implementation, but trust me, my focus is not going to be on the language delivery aspect of the things, that okay, you have to code this in C++ or Java. A lot of problems we have coded in multiple languages. Maybe some of the problems will be in C++, some will be only in JavaScript. I believe if you are somebody who is preparing for an interview, language in 2025 should not be a constraint, because most of the people can actually use ChatGPT to do language conversions. So my motive here is to make sure that you understand the concept in depth. You actually see how exactly somebody might have thought about the problem when they were carving out the problem, what can be some initial thought process, how you can actually drive yourself towards the solution. I believe these are going to be some really important videos that will be really helpful for your upcoming career. So do let us know what is your feedback. We are going to release a lot of more topics. Do let us know what all topics you want to have first, right? And the feedback is going to be important. Also, in case you are actually thinking to level up, you want to learn things with respect to low-level design, high-level design, overall system design for interviews, or you are somebody who wants to do project development in Spring Boot, you want to learn advanced Spring Boot concepts, or let's say advanced Node.js concepts, then we have a lot of courses, live courses running on algocamp.io. So you can check out the website courses.algocamp.io/learn, and there are a lot of courses that are actually listed. A lot of great discounts are actually going on all the courses as well. Do check them out. For each and every single course, we are going to add you to a dedicated Discord community where you can get your doubts resolved as well. All of the courses, we have made sure that we talk about things from the very beginner to the very advanced level that is going to help you level up in your career as a software engineer. So that being said, let's start the video without any further delay. For every sorting algorithm, we need to discuss about few properties. That is the algorithm stable? If you don't know about the property of stability, you can maybe read about it on Google. I can just quickly tell you. Stability inside sorting means that, let's say you have object 1, object 2, object 3. Okay. And let's say you have two instances of object 1. O1, O2, O1, O3. This is, let's say, O1 dash, O1 double dash. Like you have two instances of object 1. And let's say you sort it. So after sorting, if the relative order of the two objects remains same of the same object that was before the sorting, it is called as stable, right? This is stable because O1 dash was present before O1 double dash in unsorted array, and even after in sorted array, if it is present before, it is stable. But if due to some reason they got changed, it is not stable. So you might be thinking, what's the use case of stability? For example, you want to sort products. Let's say you have iPhones, right? You have iPhones, right? And let's say the iPhones are already arranged in terms of best reviews. Like iPhone 13 has got like 5-star reviews. iPhone 12 has got 4-star. And let's say iPhone 13 product red has got 3.5 stars. This is 4-star. This is 5-star. Okay. So previously it is arranged such that iPhone 13 and iPhone both are same object. So before we start this particular video, I wanted to actually talk about a very small thing. So this video is going to actually help you understand a real system design interview scenario. We are going to try to mimic a 45 to 60 minute kind of like a round where we are going to solve a problem very similar to how you will solve a similar system design problem in this short time frame. Now, of course, when you work as a software engineer in a company, you have relatively larger amount of time and you can do a lot of more deep dives in even very small level features. But in an interview, the temperament is different, the approach is different, and a similar scenario is actually explained in this particular video. So do consume the content based on that. Also, if you want to see more deep dives and want to understand these topics in a much more deeper level concepts, then do check out the link in the description section below for our System Design 2.0 cohort, where we have talked about a lot more concepts in a lot more detail, which will make you definitely a better software engineer. So let's just start the video. It's just the color is different. This is product red. This is normal iPhone, like let's say black. Now, if let's say you sort them based on price, if you sort them based on price, then iPhone 13 black and iPhone 13 product red, both are definitely expensive than iPhone 12, right? But they are still arranged such that black is before red because rating of black is better than red. So as a owner of, let's say, flipkart.com, you want people to buy the one which is having even higher rating, right? So if after sorting them based on price, their previous order, which was based on, let's say, rating, is still maintained, that's what you call stability. So a lot of people ask me, like, what's the application of stability? This can be a good application of stability. So is MergeSort stable? Is MergeSort stable is a question. So yes, we can make MergeSort stable. How we can make MergeSort stable? Like if we see the current implementation, in the current implementation, the MergeSort is not stable. Why the MergeSort is not stable? Because if you have less elements, then only you put them before. If you make it less than equal to, then just think about it. If let's say in the left half you got a 2 and in the right half somewhere also you got a 2 and you are comparing these twos, then if both of them are equal, then you will push the one which is present in the first array, that is array A, right? And if you are pushing the one which is present in first array, that means you are pushing the one which is present first in the previous order. That makes it stable. So you can just make a small change to make it stable or unstable, right? There is one more property of, is it in place? What is in place? In place is a property that is done when you are sorting outside the given array. For example, selection sort rearranges itself in the same array. Insertion sort rearranges itself in the same array. But merge sort is not arranging itself in the same array. It is taking the elements outside the current array. Here, it is taking the elements outside the current array and then bringing it back. So no, merge sort is not in place. This is another property of merge sort. Like for every sorting algorithm, we have to discuss it. Last thing, applications. So one of the biggest application is the problem of inversion count, that if you have to count inversions, so you have like there are more problems, like there's a problem on code forces, this pair of topics. This is like an exact problem of inversion count only. So these kind of problems are very easily solved using merge sort. Okay. Apart from that, the time complexity of merge sort in the worst case is n log n, which is very good. If you compare it with quick sort's time complexity in the worst case, although the worst case occurs very less in quick sort, but in quick sort it is order of n square. So merge sort's worst case complexity is better than that of quick sort's. So that's why also merge sort is sometimes preferred. Apart from that, if let's say you have to do parallelization, like if you have to parallelly sort, like if you have to do some sort of parallelizations, right, then merge sort can even help. For example, you can in a separate memory space sort some part of the array and parallelly in some separate memory space sort another part of the array, and then maybe you can merge it. Although our current implementation is not doing it parallelly, but you can do parallelization with merge sort. You can think about it, right? Just divide your array into two parts, sort some part somewhere else, sort some part somewhere else. You can do parallelization if you can do that kind of implementation. But there are disadvantages. It takes order of n space. Quicksort space complexity is log n. Insertion bubble and selection has space complexity O1. Heap sort has complexity O1, space complexity. Merge sort space complexity is quite high. That's why it's considered a disadvantage. One more application is there. Sometimes people can ask you that, let's say you have two hard disks and you have data in both the hard disk and you have to like finally sort them. Like you have a very big data, like you can't store it in RAM. You have to store that in hard disk only. You can only store that in hard disk. How can you sort the data? So you can say if you have very big amount of data, then you can like separately sort it and then later merge it using merge sort. So that is something also considered as an application. But yeah, these are the applications, or I would say advantages of merge sort, or you can say, and apart from that, disadvantages of merge sort. Right. So that's all for, I believe, the discussion on merge sort.